welcome to another deep dive. This time, we're tackling something pretty interesting, the idea of using base 12 math.
Oh, wow.
Yeah, instead of a usual base 10.
Okay.
It's also called dozenal or duodecimal, and we've got a whole bunch of sources to dig into.
Okay, cool.
We've got a YouTube video from duodecimal division, and they're looking at the geometry of it all.
Mm-hmm.
Then we've got a Wikipedia entry on the whole duodecimal system itself.
Right.
And a couple articles actually arguing that we should switch over.
Wow.
Yeah. And to round it all out, we've got a paper on the history and cultural significance of the number 12.
Sounds like a lot to cover.
It is. It is. But basically, we're going to try to figure out if base 12 really is the key to, like a more elegant math universe.
It's a really interesting thought.
Yeah, I mean, think about it. We're so used to base 10,
Right.
but it's literally just because we have 10 fingers, right?
Yeah, that's true.
So, like, if we'd evolved with 12 fingers, who knows?
Who knows?
Maybe base 12 would be normal.
I guess so.
But to help us unpack all of this, I want to bring in our expert.
Hi.
So can you explain how, like, just changing the base number actually changes how we do math, like, especially with fractions?
Sure. So the big difference is how we divide things. In base 10, every whole is split into tenths.
Right.
But in base 12, you're splitting into twelfths.
Okay.
Like, think about a clock face.
Okay.
In base 12, every hour mark is 1/12 of the whole clock.
Gotcha.
Now just apply that same idea to, well, any measurement or quantity.
Okay, so smaller pieces with base 12.
Exactly.
But I'm still not quite getting how that makes it, like, better than base 10.
Well,
Isn't it just representing the same thing but in a different way?
that's where those extra factors in base 12 make a difference. Remember, it has factors of 1, 2, 3, 4, 6, and 12.
Okay.
Base 10 only has 1, 2, 5, and 10.
Yeah, I see.
This means you can divide a whole number by 3 or 4 in base 12 and get a clean result.
Oh.
But in base 10, those divisions often give you those messy repeating decimals.
Right, like splitting $10 between 3 people.
Exactly.
You always end up with that annoying 3.333 going on forever.
Yeah.
One of the articles said in base 12, it would just be 4. No decimals.
Yep.
That would be so useful in real life.
Think about finance, engineering.
Or splitting a pizza.
About that, yeah.
Okay, now for the really out there stuff, the YouTube video we have goes deep into the geometry of base 12.
Uh-oh.
Yeah, and suggests that the universe itself might be running on this system.
Okay.
The creator talks about a base 12 Cartesian plane. I got to be honest, I'm lost here.
It is a bit much.
Yeah, can you break that down a bit?
Okay, let's start with what we know. The regular Cartesian plane,
Yeah.
the x-graph we all used in school,
Oh, yeah.
with the points plotted with coordinates and all that.
Right, right.
Now imagine a version of that, but using units of 12 instead of 10, like a grid where each square is 12, not 1. Then you plot points and draw shapes on this grid. It all looks totally different.
Almost like they're stretching and warping the whole geometry. He even shows how to divide a circle into 360 degrees using what he calls duoradicals. Basically, units of the square root of 2.
Interesting.
Yeah, it's pretty complex, but it looks amazing. And he seems totally convinced that this diagram has clues about, how the universe works.
Huh.
Yeah, it really makes you think about everything we think we know.
It does.
And get this, he asks if the mathematical ratio he gets from this diagram, it could be like a base 12 version of pi.
Wow,
I know, right? It's like, whoa, too much for my brain.
it's definitely pushing the boundaries of how we think about math.
It is. It really is. So we've seen how base 12 could, like, really simplify things and maybe even unlock new ways of looking at geometry.
Yeah.
But is it even, like, realistic to actually switch from base 10? Wouldn't we have to redo, like, everything?
Well, yeah, you've hit on the big problem for base 12 fans.
Okay.
Our whole world runs on base 10, computers, measurements, money, you name it.
True.
Even how we teach math is all about decimals.
Right. It's not just the math. It's like society itself is built on it.
Exactly.
Oh, and speaking of trying to change systems, remember that story about France trying to decimalize time after the revolution?
Oh, yeah, 10-hour days, 100-minute hours. Wild.
It totally flopped.
It did.
But it's crazy how stuck we are on our idea of time.
Right.
Even though it's kind of random when you think about it.
Showed.
12 hours on a clock, 60 minutes in an hour. These numbers go way back.
And it shows how strong tradition is, even when there might be a better way.
That's true. That's true. Which brings us to another point. The number 12 itself seems like important throughout history, not just for time.
Oh, yeah.
The paper you shared goes into this, and it's kind of freaky how often it pops up.
It really is.
12 months, 12 zodiac signs, 12 inches in a foot.
12 apostles.
Right, 12 tribes of Israel. It goes on and on.
Yeah.
It makes you wonder if 12 has some, like, deeper meaning for us, you know?
Like our ancestors knew something we don't.
Maybe. Maybe. Or some say it's just coincidence. Either way, it's cool to think about. But okay, back to reality for a sec. Even if base 12 has all these upsides,
Right.
is it even possible to make the switch?
That's the big question, isn't it?
It is, it is.
Some base 12 people think it's worth the trouble. The long-term benefits are that good. Others, they know how hard it would be. They say maybe we just ease into it, like slowly introduce base 12 ideas.
So, like, small steps first.
Yeah, like teaching it in school, making tech that works with it.
I like that, planting the seeds, you know.
Exactly.
Now, going back to that YouTube video, the guy makes a big deal about base 12 geometry in empty space.
Oh, yeah.
He seems to think that base 12 could be how we finally understand, like, the fabric of the universe.
This is a bold claim.
It is. He uses this analogy, dividing a line into smaller and smaller pieces. And at some point, the gaps between the pieces become more important than the pieces themselves.
It's like if you zoom in on something solid, it's mostly empty space anyway.
Right. And he's saying maybe base 12 geometry helps us see that relationship between stuff and nothingness in a way base 10 can't.
That's an interesting take.
It kind of blows your mind, right? Like, what if base 12 is more fundamental? Then us using base 10 is holding us back from really getting reality.
It's a possibility.
But maybe he's, like, reading too much into it.
Yeah, it's good to be skeptical with stuff like that, but I think his point is a good one. Different ways of thinking can lead to new discoveries.
That's true.
Even if base 12 isn't the answer, exploring it makes us think differently about math itself.
I agree. I agree. So where are we now? We've looked at base 12's beauty, its maybe practical uses, the problems of changing, and even if it's connected to, like, existence itself.
It's a lot, huh?
It really is. It's a lot to
Yeah.
process.
I think the takeaway here isn't about deciding if we should switch to base 12. It's
Yeah.
more about realizing that we can question our assumptions and look at things in new ways.
I like that. Man, it feels like we've gone down a million different paths today.
Yeah.
From, like, basic math to the entire universe.
Yeah.
It really makes you think about, you know, how we just accept stuff because it's what we're used to.
Right.
Like, we learned to count in base 10, so we think that's just how it is.
Just how we're taught.
Yeah, but what if it's not the only way? What if there are, like, better systems out there?
It's a good question.
Even if we never actually switch to base 12,
Yeah.
just thinking about it has, like, opened up how I see math.
Definitely.
It's like putting on a new pair of glasses.
I like that.
You see stuff you never even noticed before.
That's what these deep dives are all about, right?
They are. They are.
Not just learning facts, but like changing how we think.
Exactly. So, for everyone listening out there,
Yeah.
what do you think about base 12 now? Does it make you curious?
It is a fascinating topic.
It is. It is. Is it just, like, a math oddity? Or could it be a better way to understand numbers?
Or maybe even something more than that.
Right. We want you to keep thinking about it.
Keep digging into it.
Read those articles. Look at those diagrams. See where your own mind takes you.
That's the best part.
It is. Thanks for joining us on this wild ride into the world of base 12.
It's been fun.
It has. It's definitely a topic that, you know, brings up way more questions than it answers.
That's for sure.
But that's what makes it so cool. So until next time, keep asking those questions, keep learning, and keep diving deep.